Welcome to the UFA HPC workshop on programming HPC systems with OpenMP and MPI. My name is ClemensGrelck, and this is what you can expect from this workshop. We look at programming HPC systems from small to large. We start with small systems, just like the laptop here, with 2 or 4 cores. We look at server systems with up to 6, 8, or maybe 12 cores. But we also look at large-scale shared memory systems with virtually hundreds of hardware threads and fairly simple cores, like this UltraSPARC T series that features 512 cores with a shared memory. How to program these systems? We will use OpenMP. Why do we use OpenMP? Well, in the ideal world, a compiler would just generate parallel code for these systems out of sequential specifications. Now, experience tells us that this is very hard for a compiler because the task is very hard, but also compilers need to be conservative. The model of OpenMP is therefore simply take a C or Fortran code that is sequential and add pragmas to it, or compiler directives that explain to the compiler, in addition to the actual code, where to parallelize your code and how to do so. After that, we go on to the real big systems, clusters and supercomputers that fill entire halls or entire rooms. Here we typically have a large number of compute nodes. Each of these is equipped with multiple multi-core processors, large memories, and all of them are connected by a high-speed network. Here we need a different programming model, and we use MPI, the message passing interface. Here we have multiple processors, each running on a different node or a different machine, and knowing that there are other processors like itself running on the other machines. Now all these processors exchange messages to jointly work on a common given task. How is the workshop organized? First of all, you should bring basic programming skills in an imperative language, preferably in C, as this is one of the languages that both OpenMP and MPI use, and we will use it throughout the workshop. What will you learn? Well, you will learn how to program these systems. You will understand the different hardware characteristics and the different programming models for shared memory and distributed memory systems. And at the end of this course, you will be given some small assignments to practice programming these systems yourself. Thank you very much, and looking forward to see you in my workshop.